In this video, we will try to answer the rest of the questions asked in the previous two videos. It's recommended to watch the previous two videos before watching this one. Why is an HD entanglement operation required with our observer version? Some people seem to think that you can solve the measurement problem in quantum mechanics by a sort of reinterpreting the wave function as encoding the knowledge that an observer has about the state of the system. This is what is called a Copenhagen or Neo-Copenhagen interpretation. Now, if the wave function merely describes the knowledge an observer has, then you may say, of course, it needs to be updated if the observer makes a measurement, which is very reasonable. But this also should refer to macroscopic objects like observers and their knowledge, and suppose you want to use such concepts and postulates in your theory, in that case you are implicitly assuming that the behavior of observers or detectors is incompatible with the behavior of the particles that make up the observers or detectors. This requires that you explain when and how this distinction is to be made. The two worlds interpretation could potentially be a good candidate to solve this problem as well. The question would be the wave function would be describing the knowledge of which observer. Is it our world's observer version of you who has constituents that behave quantum mechanically and observe objects that behave quantum mechanically, or your observer from the other world who has constituents that do not behave quantum mechanically? The thinking goes that if the version of you in our world is observing some other object in our world, then the constituents of you and the object you are observing have quantum mechanical behavior. It is then expected that the wave function would be describing your knowledge, and well, the wave function needs to be updated. The assumption here is that the behavior of observers or detectors is actually compatible with the behavior of the particles that make it up. They both have quantum mechanical behavior. But let's consider the two worlds interpretation. An act of measurement or observation is required to be done on you by your other version in the other world, with constituents that do not have quantum mechanical behavior. Yet, at least, it should be having knowledge about the state of the system that the wave function is encoding or updating. Then an inevitable question comes up. What would be the source of knowledge or information of your other version in the second world? The short answer would probably be the first version of you in our world or universe is the source of this knowledge or information. This is quite counterintuitive. We proposed earlier that the entanglement operation is not necessarily quantum entanglement. We highlighted some of the potential properties of the entanglement process, and how it is potentially differentiated from quantum entanglement, which could be the operation between the two versions of you. In that case, we should be open to the idea that the mathematics of this operation might not be limited to the mathematics of a wave function. Rather, it should represent the entanglement operation and any other potential imaginary complex forces operation that could be introduced to the process. This implies that the mechanism of encoding the information is not necessarily described by the mathematics of the wave function. The basic proposed mathematics in this book for the imaginary complex forces could be a good candidate to start. Otherwise, the mathematical logic could be built differently to describe the idea. The thinking goes that there is a process of encoding the information between the two worlds and the two versions of you with a mechanism that is yet to be better understood and analyzed. There is also a probability that this process could be nonlinear. Here is a proposal of how the process might go. So, the knowledge or information would actually be projected from the version of you that exists in our world, or what we call the base space, to the total space, which is kind of represented by the straight line. Then an entanglement process takes place between this point of information, let's just call it a map sigma for now, and the second version of you. This information, or map sigma, is sent because you're performing an act of measurement here in our universe, where both you and the object you're measuring actually have quantum mechanical behavior. In this scenario, a simultaneous act of measurement on you is needed, since you require an observer, by the second version of you in the other world. But, interestingly, the second version of you doesn't need an observer, since it doesn't have quantum mechanical behavior. The knowledge or information is then encoded through some operation or maybe a set of operations which, honestly, is still not fully understood. But, it could involve scaling and projection, entanglement, creation, and annihilation operations, all driven by the imaginary complex forces that are proposed in this book. After that, the system, or the wave function, is updated with the new information. So, if we consider that a wave function is involved, it will then be encoding the knowledge or information of your observer, which is really the second version of you. This knowledge or information was initially projected from the first version of you on the base space to the total space. And, there's also a chance that different mathematics could be used for different phases of this operation. In other words, as the operation evolves, it might initially require us to use the mathematics of these imaginary complex forces. Then, as it evolves further, at some point in this operation, it can actually start satisfying the wave function mathematics. The question is simply, why? Why do we need all this loop of encoding information between the two worlds in the first place? The answer could potentially be that, simply because we need a mechanism for the first version of you in our world, or universe, to be able to change the code which is reconstructed in different dimensions, without any sort of interference or control, either from the second version of you in the other world or from any other forces. And while that mechanism actually requires such type of operations, this could be a deep philosophical discussion, and could have, deep philosophical meanings. Yet what we are concerned with for the purpose of this book is to explore the potential mathematics of these operations and see how physics could describe it in a potentially testable and reproducible manner. What happens to all the other possible scenarios? This is a fundamental question, especially when comparing the many worlds interpretation with the two worlds interpretation. The short answer is that they get erased. They never happen. And the reason could potentially be decoherence. Erasing the other scenarios here does not mean destroying the wave function or collapse of the wave function. It simply means updating the wave function in a sort of formatting all the other possibilities to either have an updated wave function with no information or with different information. Okay, so let's explain this proposal in further detail. We will start with decoherence. Decoherence is a process that happens if a quantum superposition interacts with its environment. Now, the environment may simply be air, or even in a vacuum, you still have the radiation of the cosmic microwave background. There is always some environment, no matter what. This interaction with the environment eventually destroys the ability of quantum states to display typical quantum behavior, like the ability of particles to create interference patterns. And, the larger the object, the more quickly its quantum behavior gets destroyed. Decoherence tells you that if you average over the states of the environment because you do not know exactly what they do, then you no longer have a quantum superposition. Instead, you have a distribution of probabilities. This is what physicists call a mixed state. But this does not solve the measurement problem because after the measurement, you still have to update the probability of what you have observed to 100%. Decoherence does not tell you to do that. The argument is that in the context of the many worlds interpretation, there is no wave function collapse at all. Decoherence explains how we lose the ability to see these alternate histories, the multiple branches of the wave function as it interacts on macroscopic scales. We only see what remains visible to us, stranded as we are on a single branch of the universal wave function that itself contains so much more than our little decohered slice of space-time. Yet, as mentioned above, the interaction of the quantum superposition with its environment eventually destroys the ability of quantum states to display typical quantum behavior. The entanglement of the detector or observer and the system it measures is actually a case of entanglement. That is what a measurement really is. It's an entanglement between the detector or observer and the system it is measuring. So, we have two entanglements here. The first one is the quantum entanglement between the observer, your version in our world, and the system you are observing or measuring. Both the observer and the system, have quantum mechanical behavior. The second entanglement, which is not necessarily quantum entanglement as we explained earlier, is between your version in our world and the second version in the other world that does not have quantum mechanical behavior. The first entanglement, which is quantum entanglement between your version in our world and the system, happens when you do the measurement or observation. The wave function is updated, and we have 100% probability. Yet another operation is expected to happen here, and it's related to what happens to the probability cloud of all the other possibilities if we want to move away from the concept of the collapse of the wave function. One of the potential ways to avoid the idea that everything that could happen will happen in a parallel universe, and to get away from the collapse of the wave function, is by introducing other operations that could be carried out on this probability cloud and all other possibilities to sort of, erase them. As explained earlier, erasing the other scenarios here does not mean destroying the wave function or causing the collapse of the wave function. It simply means updating the wave function, kind of like formatting all the other possibilities to either have an updated wave function with no information or with different information. This process of erasing the other scenarios, or updating the wave function so that other scenarios lose or transform the information within them, could potentially happen through the operations of the imaginary complex forces introduced in this book, including annihilation and creation, resonance, entanglement, scaling, and projection. These operations are likely to be carried out by your second version in the second world, who does not always have quantum mechanical behavior. The reason is that if you carry out these operations and your constituents have quantum mechanical behavior, then every time you do a measurement, everything that could happen will happen because of quantum mechanics. But suppose your second version in the second world, whose constituents do not always have quantum mechanical behavior, do these operations. In that case, quantum entanglement will not happen, and the ability of quantum states to display typical quantum behavior will be destroyed. The wave function will be updated, or in other words, sort of formatted by erasing the information of all the other scenarios. So if we considered the two worlds interpretation, Elvis Presley would not be still alive in other universes, singing in one of them and studying physics in another one. Yet only a second version of Elvis Presley could still be alive in the second world. The question is, what would he be doing? Is he still singing? What would the second version be doing? What we mainly need to know about the second version of ourselves, at least for the purpose of this book, is what the role of this second version is. However, in terms of how she or he is spending their time, this is an area to explore on future occasions. As explained earlier, we proposed that the second version is not within the space-time of our multiverse. We proposed as well that the constituents of the second version do not always have quantum mechanical behavior. It seems that the main role of the second version is to observe the first version, not for surveillance purposes but to enable the first version to carry out her or his own observation and measurement without interference or control, as explained earlier. It's a sort of mandatory requirement to have a non-quantum mechanical observer to close a potential quantum mechanical endless loop of observers. This observer is proposed to be the second version of you in the two worlds interpretation. In a sense, the second version of you in the second world would be like a puppeteer holding the strings for you but not controlling you. You would be giving him the directions on how to move the strings. By you, I mean the first version of you in our world. The reason that the second version of you is required to hold the strings and vibrate them as per your instructions is that the puppet's world can only work with strings. Another important role of the second version of you in the two worlds interpretation is to update the wave function of the probability cloud, all the other probabilities or scenarios in a formatting manner. In other words, your second version will be erasing all the other scenarios by formatting the wave function and updating it.